I got it working.
Yeah, there we go. So we should be able to take a look at these and write an equation as to what's going on. What's the change? Let's look at number one by itself. What is the change from x to y? What are we multiplying by?
10.
Okay, so y equals 10x. Oops, I forgot the x. Okay. What's an equation for the second one? Take a look at it and see if you can figure out what it's doing. Ty, your hand went up first. What do you see in that one?
Y equals x plus 16.
Y equals x plus 16. Do the rest of you see that and agree with him? Okay. So what we're actually saying is, if I go back to that, remember the other day I kind of drew that little box and we talked about the function, let's see, how did I draw that? I don't know. Like that. We had that opening, and if I put something in the box, when it comes out, okay, so in this case up here, if I put in a 3, when it comes out, what's it going to have? 19, okay? And that's basically what was up there. That's all it is. That says when it goes into the box, whatever you're putting in is being done by the equation that you write. So what's happening on number 3? If I put in a 2, I get out a 1. If I put in a 4, I get out a 2. Put in a 6, I get out a 3. What's going on? What's happening? What's happening here, Natalie? Oh, I like the way you say that. She says I can write it as y equals 0.5x. Is she correct?
Mm-hmm.
Is there another way I could have written it? Is there another way that I could write it, Ridley?
Y equals x over 2.
Y equals x divided by 2. Either way is acceptable. You're going to get the same thing. What about the last one over there? 20 to 10, 40 to 30, 60 to 50, 80 to 70. What is going on? What do you see, Shelby?
Y equals x plus 19.
Okay. Y equals x plus negative 10. Okay. 20 plus negative 10 is 10. 40 plus negative 10 is 30. 60 plus negative 10 is 50. Okay. What if I said x is 100? If x is 100, what is y? If x is 100, what is y? What's it going to be, Tyler?
90.
90. Okay. Does this seem difficult? Is it maybe a little bit tricky sometimes, though, just seeing what happened? And can I just test, like, okay, can I say, well, half of 2 is 1, and just go, oh, well, that's got to be the rule? Or do I need to test that rule more than once? You definitely want to test it more than once. This is what you're going to be doing today. You're just simply taking the ordered pairs, and you're determining what is happening to those ordered pairs to be able to write the equation, or the rule, as is what they call it, the function rule. Their function tables, their function machine's a lot cooler than my function machine. But basically, it's the same thing. The rule in this case was y equals 3x. If I put in a negative 2, and it goes in the machine and it does its thing, I get out a negative 6. Okay? And that will happen to whatever gets put in. It will always be applied to the 3 times x. X goes in, y comes out. Okay? A function rule is an equation that describes a relationship between the input, which this is called an independent variable. What I put in is independent. I can put anything I want in there. But the output is a dependent variable. Because the output depends on what you put in. Okay? There used to be a commercial about Reese's, and it was chocolate and peanut butter, and they ran together. And the output was Reese's. Okay? So basically, the chocolate goes into the machine, and peanut butter's sitting in there, and so when it comes out, it comes back combined. The chocolate will always be chocolate on the outside. But once it goes through that machine, it depends on what was in that machine. And if peanut butter's in the machine, it's going to come out as a Reese's, right? If I had chocolate and if I put Rice Krispies inside the machine, what's it going to come out? As a chocolate Rice Krispie treat. Okay? It's still going to maintain its ownership of chocolate being independent. If I threw marshmallow cream in there and threw it into the machine and my machine had peanut butter, I'm going to have a marshmallow peanut butter when I bring it out, right? It depends on what's inside. But what's on the outside doesn't make a difference, okay? Independent versus dependent. Where do you see those variables? Where have you heard those terms? Anywhere else? Any other subject?
English.
Language arts, there's independent and dependent. Are they clauses? Is that
Yeah, and if they can stand on its own,
Or
then they have to have an independent with it, so it can be a margin
Okay. All right. You guys know your language. Any other subject you know an independent and a dependent variable are used? What was it? Science. Science is big on independent and dependent. Okay? So we see the words independent and dependent in places other than just math. Write a function rule for the output is 5 less than the input. Now when you're writing function rules, you're always going to have two variables, a y and an x. If the output is 5 less than the input, what is it actually going to be doing? What's the rule? So y equals what? Y is where we start with. Marissa, you need to pick up your pencil. Okay? Y is what we start with, or what's going to come out. We know it's going to come out. Y equals what? Y equals what, Justin?
Y equals x plus negative 5.
X plus negative 5. Okay? Could I just say y equals x minus 5 if I want to? And for some people, is this going to follow the wording better? You're just taking the words, and we've taken written statements before and turned them into an equation. Now, though, we are saying that what comes out, our output, is our y variable. We're just giving it a variable. Okay? Write a function rule for the output is the square of the input. Everybody write it on, work with that one on their own on paper, and then we'll see how you're doing. Everybody's going to work that one on their own. You need to be taking some notes today. Where's your pencil? Did you please get it out? Just look at it here. Is the square of what's the variable?
Square of some number. So some number is what? How do you write some number? In math.
Look at what we did.
Yes.
Look at what we did on
I need you sitting up. I need you to have. How do you write? What's another variable? variable that you've been using. Well, this variable should be x, so you could look at this one and know that your other variable is gonna be x. Up here, yeah, but there's no number here. We don't know a number. X, how do you write squared of that number? Little two or big two? How do you show squared? How do you show a number squared? Does it look like this? Does it look like that, or does it look like that? Which one is squared? Which one shows x squared? You know? Which one is it? How do you show it? You show a little number or a big number? Is that what you show me?
What's being done to the input? What's it tell you to do to it? And what variable stands for the input? Look up here, look at the one ahead of it. Okay, this is something I think I need to make sure that you understand. The input of the machine is always which variable, the x or the y? The input is the x variable. The output is always going to be the y variable. Okay? That's how we knew that y had to be equal to x 5 less than x. Okay? Now on this one that I asked you to do on your own, the output, y, is, the word is means equal, is what? The square of the input, which is our x. So y equals x squared. Okay? The input will always be the x. The output will always be the y variable.
You're missing out on a lot of
Okay? Now what's it doing? We've seen this kind of stuff. What do I do with this one? Y equals 2x plus 5 when x equals 3. What do I do with this one? What am I going to do with it, Bryn? Substitute the 3 for the x. So y equals 2 times 3 plus 5. What is the value of y? This is pretty easy at this point. What's the value of y going to be, G?
11.
11. Does everybody see that? Could I test it if I wanted to? Kind of hard to do it. I mean, the test is there. It's already been done for me, isn't it? Okay. Write a function rule for the output is 1/4 the input. Again, output y is 1/4. 1/4 what?
She's switched pages. Come on, I'm not saying she's giving you information.
Do you see where all I'm doing is putting in my letters and my symbols for the written word? That's all I'm doing. Shelby?
I was gonna say, or I was gonna have you check it.
Okay, what should it read?
Y equals, well, I had 0.25 next, but it's the same.
Okay? 1/4 x, or she says I have 0.25. Why do you have 0.25? Or tell me how that works for you.
Well, 25 hundredths is equal to 1/4.
25 hundredths is equal to 1/4. Good job, Shelby. You don't want to deal with fractions, right?
Yeah.
You'd rather deal with decimals. Conversions or equivalents lets you know what that is. Yes, Madison?
Would y equals x over 4?
Would y, would that be the same thing? What's in front of the x that you don't see?
A 1.
A 1. So is it going to be the same thing?
Mhm.
Yes. Okay. What are you going to do with 2, 3, and 4? What are you going to do with those? What are you going to do, Ridley?
I'm gonna plug in the 5 for the x.
Simply plug in the 5 and solve, or the 5 variable, or the, wait a minute. Simply plug in the 5 for the x and solve it. Do it. Do the math, folks. Check with them. Check the table. Check table. Okay, finish that one. Come on. Come on. Hey, look at me. Remember what you told me you wanted. Okay, listen to me. Now's when it gets tough. Look at from this stuff. When you're tired and you don't really want to do it, that's when you find out how bad you really want it. Because if you really want it, you pull on the big girl pants. Okay, so get busy. Go, do number 2. That works for me. Quickly. Everybody agree with Cadence?
Yes.
Number 15. Who's 15? Go. I figured I can't. It's the only way I can do it fairly. Y equals 10x. Okay, everybody agree with G? Who's number 6?
Cody, he's not here.
Number 9? Nice job. Everybody sees how to solve a function if given a variable, or if given the value of one of the variables, okay? That's pretty simple. So we could solve them. We can write the rules. We've done some rules. We can do that. Okay? Now, what do we do with functions? Well, we did graphing for a reason. We're going to take what we knew, and we can create a table. All this is the input, the output, and what you get when you're done. Okay? Input, output, and the ordered pair. As long as you have a set of ordered pairs, you can graph it. Now, I would ask this question. Is this graph a direct variation? Is the graph on the board a direct variation? No, why not?
It doesn't run.
Why not?
The line doesn't pass through 0, 0.
Good. It doesn't pass through the origin or the 0, 0. Good. I just wanted to check and see if you remembered that. 7th grade has been doing that. They've just gotten into slope just enough to be able to do direct variation. Okay, so functions is tables and graphs. A function can be represented by an input-output table and by a graph. The table and the graph below represent the function y equals x plus 2. What's the slope of that function? What's the slope, Justin?
Y equals 1/2 x.
Nope. What is the slope of this function? It's right there. You got the equation of a line. What's its slope? Lindsay? White? The slope is 1. Good. The slope is 1. That's just what we were doing last quarter. Okay? It's no surprise there, right, kiddos? All right. Let's see what we can do. It says to graph the function. Now, I can do it a couple of different ways, but I can tell you, let me see, what are they going to expect? Yeah. We can graph that. Do I have to do a function table to be able to graph it? No. Do you want to be doing function tables? But I can graph it. And if I take and, let me see if I can get it to let me pull a graph over onto that. This one. Come on. There we go. Can we graph that? Sure we could. And I'm gonna number this off by, looks like ones would be enough, wouldn't it? Kind of hard to get them numbered there. So if I want to graph that, what's my slope? What's the slope? What's the y-intercept?
1.
Okay, y-intercept is 1. My slope is 1. It's positive. I can draw the line. I did that wrong again. There we go. I got my line on there, don't I? Can I figure out, if I want it, can I figure out what some ordered pairs are on that line? Sure. Okay. Same stuff we were doing. You thought you were done with it, right? Right? Nah. Because the thing is, you're going to be seeing this for the next couple of 3 years. Okay? Is the graphing going to be a problem for you in any way, shape, or form? Okay? What if I go on down to this one? Now, graph the function here, but now I have to use specific inputs. Specific inputs to be able to graph it. So if it tells me specific inputs, I'm going to have to know that ordered pair. Do you agree? The best way to do that, or to organize that, would be with your function table. Okay? My x values, there's my machine. This is x is -1, 0, 1, and 2. Now, your function table, you can put the -2x plus 1 above it, so that you know that's what you're doing every time. Okay, so basically here I've got -2 times -1 plus 1, and what does it kick out on the outside of the machine then? What's it going to be there, Michael? -2 times 1 is 2 plus 1 is 3. I agree. So then my ordered pair is going to be -1, 3. Okay, so this is my x, this is the function, this is the y, and this is the ordered pair. Okay? And I just do the same thing for each one. I plug in the value. -2 times 0 plus 1. What's it going to be when I solve that one? -2 times 0 plus 1. -2 times 0 plus 1. What's that going to be, Ethan? -2 times 0 is, plus 1 is. So what's my ordered pair there? No, what's my ordered pair? 0 and 1. Okay? If I plug in a positive 1, -2 times 1 plus 1, what do I end up with? -2 times 1 plus 1. Annie, what would I have? -1. Good. What's the ordered pair, Annie? 1, -1. Good. Okay? Now, finally, I've got -2 times 2 plus 1. Negative 2 times 2 plus 1 gives me what? What's it gonna give me? Cadence? Negative 3, so what's my ordered pair? 2, negative 3. Good. Can I graph those specific points now on the line? I could have created the line before, but I'm gonna have to be able to identify those points on the line. Because those are the ones that it told me to deal with. Yes?
Don't you just like do dots you don't draw? Or do you? Because in the book they didn't draw a line.
Yeah, they do.
Oh, one example. We did one of an example and it didn't have the line. Yeah. It just had dots. No, it was on our action side.
Yeah, but that was
Finding out.
just finding, yeah, that was just kind of playing with the inputs and the outputs. That you weren't drawing lines in the lesson ahead of us. But now you're actually just taking it that next step, okay? They broke it down. Okay? Let's see what we can do with this information. We're going to take now a story problem. And you have to write and graph the function of the story problem. Okay, now let me ask you this. They're changing it to variables G and P. Is that going to make a difference? No. You just have to know which one is the input, which one is the output. So you're going to have to identify that as you read. The number of pounds, P, of carbon dioxide produced by a car is 20 times the number of gallons, G, of the gasoline used by the car. Which is the independent variable? Which is the independent variable? Because that's going to be our X. Which one is it, Justin? G. So the gasoline is independent, so we're going to change it and we're going to call it our X. If it's the independent variable, which is the dependent variable? Which one depends on the gasoline? Which one is the dependent variable? Which one's it going to be, Joey?
Pounds.
It's going to have to be the pounds of carbon. Okay? So this has to be the output. So you know you've got to have Y equals something. Now, go back to the story. And if I even just look at the clue words here. Is, that's my equal, isn't it? Y equals, and then here it says 20 times, that's multiply, right? 20 multiplied by X, so this is 20X. Is that going to be my equation? Is that my function rule? Sure is. Now we've got it written, you're going to have to be able to graph it. Now, on this particular graph, you have specifics, things that are going to matter. Because it's not just an X and Y anymore, just a random X and Y. It's a specific X and Y. Specifically, X stands for what? Gas, good. So when you go to graph, the X's are your gas, and you would note that this is gallons. It's a label on that graph. What's the label on the y-axis going to be? What does the Y stand for? Pounds, good. Pounds of what, though?
Carbon dioxide.
So this is carbon dioxide, and we know it's going to be in pounds. So that way, when you look at that graph, you can tell exactly what it is. It's not just a random bunch of numbers graph anymore. Now it's got a meaning to it, okay? It stands for something. So when you create your graphs, you're going to want to add this feature to your graph. You've got to label your graph so that you can understand what's actually being graphed here, okay? What if the truck P is 25 times G? For a truck, P is 25 times G. Write and graph the function that describes the relationship. Where it's using the same info, we're changing up the data just a little bit though. So what's the new function rule going to be? What's the new function rule? What do you think, Lily?
Y equals 25x.
You got it. It's a little bit different than the one before it. Which one of them is going to have the steeper graph? Which graph is going to be steeper? This one, the original, or this one? This one. The truck's definitely going to have a steeper graph. Why? How do you know it's going to be steeper? How do you know it, Natalie? Yeah, the slope, the 25 is my slope, so that tells me it's going to rise quicker, isn't it? Okay? How do you feel right now? Do you think this is something you can do? Okay? I think it is. Matter of fact, I'm going to give you the assignment, and it has nothing to do with what it says right there. We're going to take that off. Math journal. You know, when I say math journal, it's a small assignment, which you like. You're going to turn to math journal page 128. You're going to need to write this down because it's not printed on what you have. And then you're going to do textbook page 255. And it's 39 to 42. That's your assignment.